Okay, I can't help focusing on SLIM topic today because we just made a nice successful landing on the moon in January. So SLIM is a small mission. It's about technology demonstration about pinpoint landing. So nowadays we talk about Artemis, and I'm sorry to some of you, maybe I should say, that Japan will be the first non-US to provide the lunar astronauts, but this doesn't come for free, of course. And it comes because we will be making a big contribution, pressurized rover. And because it's such a big contribution, I'm kind of dragged into the conversation of what kind of science we will perform by pressurized rover. And I hope Lori will help us, making this a big success. But so these things are great, astronauts on the moon and pressurized rover. It's a great thing. But on the other hand, I would like to emphasize that big thing doesn't take it all. Big thing will set the nice framework, but there will be some rules, good rooms for the smaller missions to play a nice role. And that's where SLIM comes in. SLIM is like a precursor mission for us to establish a technology for the OK-sized mission on the moon and also on Mars. So what happened in January this year, about a half a year ago, is that we started the landing operation at the altitude of 15 kilometers above the surface of the moon. And we started the powered descent phase. And we came down to like 7 kilometers above the surface of the moon during which we did have 3 occasions of performing the optical-based navigation, and only performing it just 3 times. The position accuracy was as small as 100 meters at the altitude of 7 kilometers at the end of this powered descent phase. Then we started a vertical descent phase from the altitude of 7 kilometers. We performed 12 optical-based navigation during this vertical descent. And at the altitude of 50 meters, when we were hovering, the position accuracy was as small as 3 meters. It's not 3 kilometers. I'm saying 3 meters. So 3 orders magnitude, more than 3 orders magnitude improvement from the conventional technology. So this really matters. And I think at this moment, we have demonstrated the pinpoint landing technology. So it's only 50 meters left, only 40 seconds left. We thought it's going to be a piece of cake. But what happened is that, as you can see from the image on the surface of the moon, there's something sitting on the surface of the moon. It's not that somebody else situated it. It's us that dropped one of the nozzles of the main thrusters. So we lost half of the thrust of the main thruster, and the spacecraft, of course, turned into the contingency mode autonomously. So we have to drop many options. But still, the spacecraft autonomously managed to reduce the vertical speed, so we didn't crash onto the surface. But because of the unbalanced thrust, we had a non-small horizontal velocity. So upon landing, the spacecraft kind of tipped over. But still, it was a soft landing. We recovered all the data. That's why I can tell you I can reconstruct and tell you all the stories that happened during the landing operation. But we ended up in an off-nominal orientation. So how off-nominal was it? It was like this. And we would have been a genius if we planned to land like this. But of course, that's not the case. And but you might be asking, you might know the story already. But the question is, who took the picture? Right? And during even in this contingency mode, we somehow kept the option of releasing the 2 small robots to the surface of the moon. And if you look at the textbook, maybe it's something we shouldn't do. And I had a chat with the team members why we kept this option. It's a really nice story to tell. Maybe we can talk about this over a glass of wine or something. But still, because the team kept this option, we had this nice robot, 200-gram-ish, a baseball-sized robot, and it was coming from toy company and Sony. You know what Sony is, but Takara Tomy is a toy company, and this nice contribution from the industry really made this nice story happen. And what happened is that during the descent, even in the contingency mode, we did release 2 robots. And one of them autonomously looked for SLIM spacecraft. And then when it finds that the SLIM is in the frame of the camera, it took the picture and it selected that particular image and sent the data to the other small robot. The other small robot is like 2 kilogram-ish, so it's still small. It's the other small robot, 2 kilogram-ish robot that sent the data directly to Earth. So we managed to do the inter-robot communication on the surface of the moon and the direct communication to Earth by 2 kilogram-ish small robot to Earth in this mission. The place we landed is where we think this crater formation process excavated the deep interior rocks to the surface. So if you land next to that rock from the deep interior, we can study about the deep interior of the moon. That's the plan. And after the illumination was getting favorable for this orthonomial orientation, we did manage to get the spectroscopic observation of the rocks sitting next to the lander. And we did identify olivine as the minerals inside the rock, which should be coming from the deep interior. So the study is going on, but we did land in a promising place to do the study that we had planned. So it's a small mission and it's a smart mission as well. Pinpoint landing, as well as, 2 small robots alive and kicking on the surface of the moon. And so this is really, I think it's going to be an iconic image in the history of the space exploration, I hope. But at the same time, this really tells us something, because we had planned to make SLIM land on the surface in this orientation. What I mean by in this orientation is that you land like this, and then you kind of try to clinch onto the surface of the moon so that you can land even in a slope area. And if we had managed to demonstrate this, if the thruster didn't drop off, and if we had managed to demonstrate this, we could have, casted the kind of a philosophical question to you today, like, is landing on legs right choice for this size of the mission? If you look into the history of all the landing missions, legs tends to be beefy. But from now on, like including commercial missions, we want to have a small and smart missions. And in this regime, is the landing leg right option or not? I could have asked you this question, but unfortunately we didn't demonstrate this. But yeah, we'll see. We'll see if we will have another mission like this to have a chance to ask this question to you. And yeah, that's all I have to say today. Thank you very much.